Hey folks, Todd Coburn here, and this little video is for teachers, specifically teachers teaching engineering courses. Of course, I developed this for my own courses, and so it's directly applicable to aerospace structures classes, but really some of these ideas will apply to any of you teaching university courses, and especially courses in engineering. A few years ago, I was asked to share some of my high impact practices with the College of Engineering at Cal Poly Pomona, where I teach, and I developed this little presentation. So this is a little outdated, but the same principles apply. And so let's go quickly through it for any of you who are interested. Okay, 3 high impact practices. The first one is homework. So homework can take an enormous amount of time to grade for teachers. But homework is critical because students learn by doing. I often tell my students that sitting in a good lecturing is like chewing. When you watch somebody lecture, it's like chewing food. You get the aroma of the food. You get the flavor of the food. It either tastes good or it tastes bad. If it tastes good, you've got all this wonder and excitement about what you've eaten, how good it tastes, and also the effect it's going to have on your body and making you ripped and strong and healthy. But actually, chewing doesn't do anything for keeping you healthy or strong. All it does is give you the anticipation of getting healthy and strong and the idea that you're getting healthy and strong. So sitting in a lecture is like chewing. Homework is like swallowing. When we swallow, the food that we're chewing that we think is going to give us nutrition goes down and now can be absorbed into our body. So lecturing is like chewing, and swallowing is like homework. So what happens is when students do homework, that's like swallowing the food. Now all those ideas that they were excited about, that they learned about, that they smelled and they tasted, come face to face. Often if a student waits too long before doing the homework, they can't even do it. They understood it in class or thought they did, but they can no longer do it. So the sooner they do that, the better. And that doing reinforces what they learned. It identifies any holes in their knowledge, and that's what actually gives them the nutrition that causes that content to become theirs. So lecturing is like chewing, and homework is like swallowing. With that in mind, it's critical to give enough homework. If you have a class with only a couple little topics, it's pretty easy to have a few questions covering it. But if you have a diverse class, the class of statics, structural, where we develop structural loads, is actually based on only a few principles, but the way it plays out in different situations has got countless variants. So homework is critical to be big enough. Our Structures 1 class, we learn all the basic analysis techniques, has a number of really easy techniques, but there are so many of them it can be hard to recognize which one to apply and how to apply it. Other classes like finite elements require very deep and composites, deep solutions and understanding. And it's the homework that actually makes it all come home. So it's critical to give enough homework. I give a lot of homework because that's where students actually learn the material. Now with all that homework, all the student work, you've got to give credit for that. You don't really want to give zero credit for something that really is going to take so much time of the student. At the same time, students are working on this homework together, and so what they turn in is not necessarily their work. In fact, you can tell a student that does a lot of homework but then scores and looks like they're doing really well but scores poorly on quizzes and exams. It's usually because they're not doing the homework. They're actually getting too much help from other people. I mean, they're doing it, they're putting the pencil to the paper, but they're sitting in a group every time they get stuck. Did you get this one yet? Did you get that one yet? How'd you do this one? And when they do that, what it does is it causes them to never actually learn the material. You actually kind of have to sweat and bleed a little bit when you're doing the homework in order to actually learn the material. And the more you sweat and bleed doing your homework, the more that homework is yours. So while group work is fine, students need to spend enough time working on their own to figure these things out. They need some credit, but it shouldn't be too much. So I give about 10-ish%. Usually I adjust that based on the class and what the score, the intent of the class is. The problem is now you're giving credit for homework, and it can take an enormous amount of time to grade that homework. So I developed a little rubric where basically every homework assignment, I give them the answer at the bottom of the homework assignment. So some folks are assigning problems. If you have a really good textbook with a lot of example problems, a lot of times they'll have the answer in the back, and then you'll have to develop your own homework. But with my classes, we're actually treading, while we do use a lot of content that has good books backing it up, a lot of times we're treading between and around and focusing on different things. So I develop all my own homework. So that homework, I give answers, not solutions, but answers to all the problems. So when they work the problem, they can look at the answer and know they're right. Now the problem with that is students will end up too focused on matching the answer, and they're not actually working through the problem. They're just looking, does this work, does this work, does this work? Sometimes they'll match my answer. They won't know why, and then this shows up on their tests. Regardless, that's how I do it. And I have a little rubric where they need to develop. In engineering, students need to not just get the answer. It's critical that we have appropriate documentation, especially in aerospace, for everything we do. It's not sufficient to have an aircraft that is good structurally. It has to be good, and it has to be documented to be good structurally, so the certifying agencies can check. So students in engineering need to learn this skill. So I have a procedure that you'll find in any strong engineering foundational text, including most mainstream statics texts, dynamics texts, and structural mechanics texts. Sometimes fluids texts will all recommend the same procedure of writing in any homework problem to say given, and you repeat what's given, find, you repeat what you're looking for, and solution where you give your solution. So I have a rubric where they get points for setting up that problem in that way, and then working the problem to completion, and then more points if they get it right. I base it on a 5-point scale. Every problem worth 5 points. Sometimes I'll tweak that for various homeworks, but that's my basic rubric. Every problem 5 points. And this is what I put in my syllabus so students know how to grade their own work. Then what they do, they go and grade per the rubric. They put their score in the prescribed manner on the top of the page, points over possible. I often give extra credit. I expect a lot out of my students, and I expect a lot out of myself. So if they're doing something and it's fun, plus it's fun to give extra credit, it's fun for them, fun for me. So I'm throwing out extra credit all the time. So a lot of times their homework will have points over possible, and then they'll also be claiming extra credit. So in my rubric, I tell them how that is done. And I think I have an example here where this is a typical self-graded homework problem. This is one of my students. They're actually marking, this is not required, but they'll mark the points next to each, the given find solution, and the working to the solution, and then getting it right or wrong. That's 5 for the problem. They'll count that up, and then this person, they're calling out, here's the class, this is the homework. They have points over possible. This particular one, I was collecting 2 homework assignments, and whenever I collect multiple assignments in the same delivery, then I have them separate what those homeworks are. So this one's claiming their points over possible for each. This particular one has no extra credit. If there were, that'd be off to the right somewhere next to the grade. So this way, I still have to go in there and record these grades. I used to do it with a big stack of homeworks, and I'd go through it pretty quick. Now they upload their homework to Canvas. I take a look, and if it looks good, I give them their grade. So it minimizes the time I need to spend grading. I can look and make sure, yeah, the student's kind of doing it. Looks like they're going through the process. They got the right answer. Looks like they're all is good for the student. I can do that pretty fast. as long as I don't get bogged down in the details, then I can address any students that look like they're underperforming early on. So this is one approach to homework. It's not the only one. There are many great approaches. This is one that can be done and that I have used and that might be useful for you, particularly if you're teaching engineering. Okay, so this is some of the basic ideas. I make them put the homework. I put their, another thing I do whenever we have a hand turned in assignment. So while homework is all uploaded electronically, my quizzes and tests are both turned in class, hard copies. So I have found I can spend a inordinate amount of time trying to sort the different assignments. Students write their name different places. They write with different legibility. It can be very challenging and take time consuming to sort those in alphabetical order. So one thing I've developed is I have them put the first 3 letters of their last name. Like this particular student, if their name was Amorato or Amorica or something, the first 3 letters of their last name. So for me, Coburn, it would be C-O-B. It's not your initials, it's first 3 letters of your last name. That serves to, so then what I'll do is I'll have the stack, I'll just go through them and I'll throw all the A's through H's in one pile, all the I's through P's or Q's in the next pile, and the rest of them in another pile. So I'll just go throw them into 3 piles. I'll pick up the first pile and I'll sort them in A's, B's, C's, D's, whatever, once again in groups until I get the subset grade sorted. Then I'll do the second stack, third stack, and now I've got them all stacked, sorted. And this, having them put the first 3 letters of their last name at the upper left corner, that makes it easier, so I just can focus on that corner. If they write that in capital letters, it's a lot easier to see than finding their name and their different legibility letters and this kind of thing. So I require their full name on the homework plus the first 3 letters of their last name. I also have them, sometimes, not always, have them put the due date, the score of each, the points they're claiming over the points possible. The reason I do this, not just the points they're claiming, is because students make lots of mistakes. Sometimes they will claim the wrong number of points, and if I just see the score and I have some gripe with I disagree with how they graded their homework, I don't know immediately looking at the score whether it's because they misscored this or whether they're claiming full credit or partial credit or what. So to make sure that I know that they know how many points were on the homework possible and whether they're claiming full credit or something else, I have them call out points over possible. And then if there's extra credit, I have them put it off to the right. If they ever don't match my solution answer, they're not actually allowed to claim full credit, but I do make mistakes. And so the intent is not to be overly burdensome. So what I do is I encourage them, if they think that their answer is right for some reason, they've looked through or they feel like it's close enough for government work, then they're allowed to claim credit, but only if they flag the problem and flag it up here on the title page. See problem, blah, 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 because for whatever reason, they're giving themselves credit, but my rubric didn't allow them to. So I encourage them to do that. Worst case, if they claim it like that, I will just adjust the points as I see fit. But if they don't claim it and they give themselves full credit for something where they don't match the rubric, then I penalize them rather healthily. So that's just one approach that I've developed that also seems to work. Okay, so there's some ideas for that. And yeah, that's pretty good there. Okay, next idea. So that's how I deal with my homework. So what that does, it gives them some credit for doing all that work. And now classes like composites and finite elements, where there's a huge amount of homework and it's kind of in practice, not just a few problems where they're matching answers. So they've already got a lot of skin in the game, a lot of time invested. Then I push that homework score up a bit because that work is worth something, even if they're not able to score anything on the test. It's got to be scored so that you can't pass or do well in the class if you don't actually master the material, but it should be worth more points if they actually are doing an inordinate amount of homework. Okay, next idea. In-class PowerPoint quizzes. So a few years ago, our school got a little bit picky about printing off papers for students. So I started using PowerPoint quizzes. And here's how it works. Now, the benefit of a PowerPoint quiz, normally students take a quiz, they turn it in, they either think they get it right or they think they get it wrong, and then they don't see it again until I turn it back, and by then they've completely forgotten what happened. So what I do is I have a PowerPoint quiz where I show the quiz, they work the quiz, they turn in the quiz, and then I immediately show the solution immediately after. I don't write it out on the board because that's time consuming and we have a class to cover. I have a PowerPoint where I've developed a nice, sometimes just the answer with the approach written all out. Sometimes it'll go step by step and walk them through the process depending. So this gives them immediate reinforcement for those principles. It actually takes between 5 and 10 minutes. Now the thing with my quizzes is obviously some problems, especially engineering problems, can take 1 minute, 10 minutes, 5 minutes, 20 minutes, an hour and a half, depending on the problem. So for quizzes, I keep them really simple. Like when they learn to do stresses, what's the stress for a part? It's just P over A, two numbers put together in the appropriate way. What is the force on something with multiple forces, axial forces, things like this. Super easy principles and sometimes conceptuals where they just, it's like a true, false, or a yes, no answer. So I have a bunch of these quizzes. They're really easy. Most of them take between 1 and 5 minutes to solve. I mean, we're talking really easy, really quick solutions. However, if students haven't done their homework or they really don't know the principles, then they fumble around, thumbing through their book back and forth. So while the quiz takes between 1 and 5 minutes, often I'll give my students 10 to 15 minutes to do it. I do this right at the start of class, right at the start. So students walk in, hits the time of the class, bang, that quiz is up, students are working. Anybody who's late to class is late to the quiz. And if they are very late, they're going to miss the quiz altogether. So I don't like to babysit my students or chastise them or take attendance for them being there, but this is one way of rewarding the students that are there and training the students that they need to be where they say they're going to be. If they took a class, they should be there. They should be there on time, actually early, and be ready to study throughout the entire class. And this reinforces that. Okay. Another thing I do, I don't think I have it in my best practices, a few years ago I started giving negative credit for any missing assignments. That means negative 20%. So if they don't do a homework, it's minus 20%. If they don't take a quiz, it's minus 20%. If they don't take a test, minus 20%. I started doing this because I realized I've got students that are working very, very hard, but really are struggling with the ideas and can't put points on the board. So I've got a lot of times, especially for quizzes, zeros from students, even though they're super easy. Other students didn't even show up. There's a difference. As an employer, when I have an engineering team, if I have a weak employee, I can still find useful places for them to be productive if they are working hard, show up on time, and are willing to try. I can find work for them where they're effective, and I can guide them in growing. But if an employee doesn't show up, I can't do anything with them, and it actually undermines everything we're trying to do. Actually, the worst employee is somebody who's very sharp but doesn't show up when they're supposed to show up. So this is one way of helping them learn this, negative points for missing assignments. And anyway, so back to my in-class quizzes. We're talking about a quiz, and I'm going to show you how this works. We're going to show the quiz just like we do in class. We're going to show the solution just like we do in class. So imagine walking into a class, one of my classes. You're taking the class, you've been doing your work, you're there early, you're sitting down, you're getting ready for class, you see that I'm preparing the quiz up front, and so you get your paper out and you get it all ready. Once everybody's ready and our class has started, I'm going to flip the next slide. These are some of the things one of the things we talked about before. In fact, often as students are walking into class, they will walk in and they're going to see this on the slide. That means, hey, it's Christmas time, we're having a quiz. And so they get down and they get ready, everything ready. And as soon as class time starts, I will call the quiz rules apply. That means they can't get up unless they're done. They can't talk or communicate. They can't share stuff, pencils or anything else. And I show the quiz. This is a typical quiz from our Structures 1 class where they're developing a singularity function for this loading. That's a critical first step in developing what the internal loads are on the beam so we can figure out whether it's good or not. This is a very basic process. Some books make it hard. My book makes it pretty easy. And this is actually a really easy question. It asks them to write the singularity function. So I'm showing this slide now, and all the students start working. They're working, developing their solutions. They're not allowed out of their seat. They're not allowed to communicate. If they have a question, they have to raise their hand. But when they're done, they're allowed to come up and bring their paper, put it face down. So eventually one more, and usually I'll watch my slower students to make sure that they have enough time if possible. But you can kind of tell when they're actually working, moving forward on a solution, and when they just have no idea and they're just flipping around in their book. So I'll watch the class, and when they are done, or I feel like more than sufficient time has passed, then I'll flip to the next slide. I've got all quizzes now in hand, and this is just here so that I don't accidentally flip it to the solution while students are working on it. And then I show again the problem, and then I show the answer for this. This only requires one term. This identifies the singularity function. They look at their book to the right page. They see this as a negative moment. They put the magnitude there, MO, the form of the singularity function x minus, and then whatever the x position of the starting point is. In this case, it's a, and the proper exponent. This is super easy. Should take them less than 3 minutes to solve. Or if they're really slow, 5 minutes. And so that's how it works. Students walk in, they see the slide. Once I've collected all, I flip to the next slide, and then to here, and then we talk about it. I'll say, now, wasn't that easy? And students go, oh man, that was so easy. I knew that. I said, how many guys knew that? How many guys paled that problem anyway? So you get people who are excited because they nailed it. You get people who are disappointed with themselves, but they realize, oh, I should have had this. Yeah, I knew that. I knew this. Oh, I forgot the negative sign, or I forgot that it's the starting position that goes in that first little digit, that A digit, or something. So, and if they have any questions, I can answer them directly. And now we're off and teaching the class. And this takes usually less than 10 minutes. Almost always less than 5, okay? So that's high impact practice number 2. High impact practice number 3, I actually started developing this before COVID. And then when COVID happened, I kind of went on steroids. Originally, we were doing all of this, our electronic delivery in Blackboard. And then we switched to Canvas right after COVID hit. Actually, Canvas is superior to Blackboard in a lot of ways, but Blackboard is superior in the questioning, on the questioning part. The Canvas has some notable defects that even after multiple communication with the Canvas folks, they are uninterested in correcting them. But anyway, I worked around that. I uploaded all my Blackboard solutions and I've worked with them. I use them a little bit less than I did with Blackboard because of the issues with Canvas. But now we're doing this in Canvas, the same kind of things apply. Basically what this is, and then when COVID hit, then we were going all electronic, and then I had to develop my whole electronic testing. In that case, I came up with something like 1,000 questions per class, grouped in maybe 20 to 100 different problem sets, so that I could give each student a unique experience. So what it does now is when I set up a quiz in either Blackboard or Canvas, I can make a question and I can pull from either one or multiples of my little quiz sets, and then identify the names so that I can tell what lecture this problem covers, how much time they should have, like whether it's a 1-minute question, which means like seconds usually, like is the sky blue or yellow? That's not a great question because the sky can be yellow, but really simple. It's 2 + 2, 4, right? This should take like 2 seconds to answer, and then maybe 2 seconds to check. And if a student is really weak and is worried or is an overthinker like many of my students, maybe they'll take a few minutes thinking about it to make sure it's correct. that's how many of these questions are. Others take more time with simple calcs. So this is actually what I'm going to show here is for Blackboard. It's similar for Canvas. So what I do is I set up these problem sets. This is actually how this looked in Blackboard before we switched to Canvas. And in these test surveys and pools, that's where you could set this up. So this actually is showing you how to set up pools, and then you can create tests and homeworks from those pools. This is how this looked like. For example, in our Structures 1 class and 2 class, we use, they need to be able to find in the appendix what the material properties are, like the ultimate strength and the elongation and things like this. So this means I have 9 problems in that. At this time I had 9 problems just on elongation in one little pool. I had 10 problems on the compressive modulus and so on. I had 7 problems on using appropriate significant figures, 12 problems on my syllabus. So actually I can create now a test or a quiz or whatever by selecting, hey, I want 1 problem from this data set and then 5 problems from this other data set and maybe 1 problem from another data set. And this is my old naming. My new naming also has a little indicator to say how long it will take for each of these, like 1 minute, 5 minutes, 10 minutes, and that kind of thing. So this shows kind of how those pools are set up, and then we can put them together in, and this is how, like if I'm doing a SMART problem, how I can put in dimensions, and then it modifies the text so that it gives each student a unique experience. This gives like this particular problem, this is a little, an open cell beam where we have a thin-walled closed section, where when applied to a torque you get a shear flow going around the thing. They need to be able to solve what the shear flow is in any web, what the angle of twist is, what the stress is in the different webs. And by setting this up like this means each student will get this problem, but they'll all have different answers. Not all, because they can get the same problem, but it's going to be randomized. So the chance of them asking or getting help from a student with the same problem is greatly reduced. And if they're cheating, like coordinating on the phone or something, they actually have to resolve it for the other and can't just share their answers in a text. So this kind of is one way to develop these. This goes through the rest of that process where you set up now a test, calls it a test, but you can use this for homework or quiz or whatever. So I was using this first to reinforce principles, to give students a little more immersion, in addition to the homework, which now they, remember the homework, they have a prescribed procedure. It takes some time to write everything out. With the these online quizzes, unless it's a written out problem, they can actually just yes, no, B, answer B in a multiple choice, or do a quick calc and just drop in the answer. It's much quicker, and it gives them good reinforcement. So this is one way to reinforce these ideas with students in addition to your homework. Okay, so that basically is my 3 highly effective practices. One is homework and the self-grading that they do for the homework. 2 is the quizzes, the online quizzes, where we show the quiz at the start of class and then give them immediate reinforcement. And 3 is using Canvas or Blackboard or some way of creating problems and giving students extra immersion. Now, some textbooks, like many of our statics and dynamics texts and things like this, the publishers now have developed stuff like this. So if you utilize the online text, then you can actually utilize, they do all the work developing the problems, and you can just select which problems. It's kind of the same idea, but they're doing all the heavy lifting. That's good. The problem with that is now students have to buy an electronic access to those problem sets, and often teachers that do that make the textbook electronic as well, which means students only have access for a period of time. This is actually a bad practice, because every student in engineering is going to need most of their engineering books later in their career. They need to have their book, they need to be writing and highlighting in their book. And so now we've added an expense to the students, and we have undermined the practice of a hard copy text. So by doing this yourself, if you create your own problems, and that is extremely time consuming, you can actually create a better experience that's more cost effective for your students. And that's what I've chosen to do. Anyway, those are my 3 highly effective practices. I hope they help you. There is certainly more than one way to skin a cat, and there's a lot of great things being done out there. So take this for what it's worth. Hope it gives you some ideas. Go out there and be great. Thanks for listening.